Okay. So let us see this question, guys. Asked in 2025 NEET. What is this question about? So here we have two inclined plane surfaces and they are inclined at same angle 45 degree, right? Then one of them is rough and other is perfectly smooth. So as you read this question, you start visualizing, okay, I have to consider two inclined planes. Let's say these are two inclined planes. Angles are same 45 degree, 45 degree, right? But one is smooth, mu is 0, and the other one is rough. So let us consider that the rough one has a coefficient of friction as mu, right? So a given body takes 2 times as much time to slide down on rough surface than on the smooth surface. Obviously, you will consider that on rough surface, a body of some mass will take more time to slide and reach to the bottom compared to that on a smooth surface, right? So here the time taken, let's call this T1 and let's call this T2. Then according to the question, that T1 is quite more and it is exactly twice of T2, right? So what influences the motion here? What decides the time? So if you have learned this concept, you will know that you can directly apply kinematics, right? They will travel same displacement. S equal to ut plus half at square would be the important equation that can help you to solve this problem. So but the accelerations are different. That's the part in the smooth part and the rough part. So what are the acceleration, guys? So on a rough surface, acceleration is given by mg sine theta minus mu mg cos theta, right, divided by mass. So if you remember, this comes out to be g sine theta minus mu g cos theta. Let's call this A1. What will be A2? Which is on the smooth surface. On smooth surface, there is no friction force, right? So only force acting down the plane is mg sine theta. Divided by mass, acceleration is g sine theta. You must be knowing it when you go to the exam, right? Now these are the accelerations. So let us now relate the same displacement with different acceleration and different time in these two cases. So let us talk about first case. You will write what will be the equation. We'll write S equal to ut plus half at square. U in both the case you can safely assume to be 0, considering that the object might have started from rest. So you will write, okay, ut plus half at square. If you look for this term in both the cases, S is common, A is different, right? So if you see how the time varies with S and A, or how it is actually related to A, so the time is equal to 2S by A, in fact, is square of it. So instead of solving the second case, you can just work on the proportionality here. S is common in both. So time square will be proportional to 1 by A, or T square will be inversely proportional to A. So you write, it looks like T1 square by T2 square inversely proportional to A. It will be, okay, it will be A1 and here it will be A2. And now just check inversely proportional, right? So that's how you can solve this problem. Let's go ahead and see what are the ratios of acceleration and time. Let us substitute now. And this is the final climax time for this question. So T1 is 2 T2. So we'll write here, okay, in this case, it will be 2 square. And acceleration, second case is g sine theta. And in the first case, it is g sine theta minus mu g cos theta. G will get cancelled, and as the angle is 45 degrees, sine and cos both values will be 1 by root 2, 1 by root 2. So without any hassle, you can cancel them. G sine theta, G cos theta, all these will cancel. You'll get 1 upon 1 minus mu over here, and that will appear as 4. Now let us go ahead and solve this. You'll get 1 minus mu is equal to 1 by 4, right? So mu is equal to 1 minus 1 by 4, which is 3 by 4, which is 0.75. And that's how you will get your answer as 0.75. Okay. So the question is based on kinematics, and you need to know the acceleration of rough surface and acceleration on smooth surface and relate the common displacement with the acceleration. Okay. So see you in the next question.